Hi, welcome to a video on some derivatives of exponential functions. These couple of examples that we're going to do are going to involve the chain rule. So, starting with our first example, we've got a function here, 5x minus 4e to the x, that's raised to a power of 3. So we have an inside function and an outside function, so that's going to require a chain rule. So when we do our derivative, our dy dx, remember the chain rule says do the derivative of the outside function first. So that's going to be our power rule, where we bring the 3 on the outside to the front. Remember, keeping the inside function just exactly the same. We just rewrite it. We don't do anything with that. So 3, lower it to the front, lower the exponent by 1. Then multiply that by the derivative of the inside. So now what I'm going to do is do the derivative of 5x, which is 5, minus the derivative of 4e to the x, which is just 4e to the x. And again, I'm following these derivative rules here with the e to the x. Okay, let's see. Is there anything I can do to clean this up? I could distribute the 3 to this second term here. I can't distribute it when this first term here has a power on it, but let me just rearrange. I'm going to put the monomial first, followed by this factor, and then leave my 5x minus 4e to the x squared last. And I think that would leave it just like that. I don't think it's worth it to distribute the 3 because usually we like our answers in a factored form. So this would be complete. Okay, our next example is going to involve another chain rule because we have an inside function here, this 8 plus 6x. It's inside of a square root function. And before I even go any further, I'm going to rewrite that square root function as an exponent. That's going to make it very similar then to the problem I just did, where I have an outer function, which is the exponent, and an inner function, which is the 8 plus e to the 6x. Okay, so starting again, chain rule, derivative of the outside, so 1/2 moves to the front, leave the inside the same, so let me write that down, and then we're going to lower our exponent by 1. So that 1/2, if you subtract 1, becomes negative 1/2. So there's my derivative of the outside. Multiply that by the derivative of the yellow part here. So the derivative of 8 is 0. The derivative of e to the 6x is e to the 6x multiplied by the 6. Again, chain rule, doing the derivative of the 6x. Okay, so cleaning this up, well, let's see here. I have a 1/2. I'm going to take this e to the 6x times 6 and put that here, 6e to the 6x. This negative exponent, I probably will throw that to the bottom of our fraction. Usually we like our exponents to be positive values, so probably that will work well for me. So here I'm going to take 1/2 of 6 and I'll make that a 3. So let's keep going here. So I'm going to end up with this 3e to the 6x. Let me take this negative 1/2 power and bring this to the bottom, and then I can make that power a positive 1/2. Okay, so what happened was this all just floated down to the bottom here. And then maybe one last step here. Let's take this exponent of 1/2 and rewrite it back as a radical. So I like this way of writing our answer. So we have a square root on the bottom, 8 plus e to the 6x, and that would be a nice form of our answer. So this was a chain rule problem with an inside function here in the yellow and an outside function of this power of this 1/2. And so therefore chain rule comes in handy for many problems. Thank you. I hope this has been helpful.